Hey, what is going on, guys, and welcome back. And in this video, we're going to finally finish section 6 of part 4. We should have gotten through this about a week ago when I uploaded the previous video, but um, I wanted to take a little bit more time just to think about this final exercise because it is a little bit of a challenge, and I wanted to be able to digest it before I can explain to you guys what I'm thinking and how we're going to approach solving this exercise. So section 6 in part 4, the final exercise of this subsection, which is this exercise called grade statistics, which is, I talked briefly about it in the previous video that I was going to cover in an independent or dedicated video towards this exercise as it is. It's exercise 38, so if you're going through the exercises list, it's exercise 38 in part 4, section 6. So this exercise almost broke my flow in the course because normally, if you guys have seen in previous videos, I do all the exercises together either in batches or in one video, and we go through them and it's no problem. But this one is a little bit trickier because um, it sort of builds onto one of the other exercises we did a while ago, and it also plays into the sort of bigger idea in programming, which is working with data and doing something with that data, whether that's data that's hard coded or that's data that we're reading into our program and then we're doing something with that data. So in this exercise, we're not just reading input and then printing it out. We're building a small grading program, right? I didn't want to call it a machine, but that's what we're doing. We're building a program that's going to read student grades and then do something with that with those grades. So I'm going to try to break it down to you guys and talk to you guys about what I'm thinking about as we're going through this. So I'm going to read the exercise information as we always do, and then we're going to start. We're going to open up VS Code. I already have VS Code opened and prepped for this exercise. I already have the TMC extension open. I have the workspace open, and so we're just going to get straight into writing code after going through the exercise information. So it says in this exercise, you'll write a program for writing out grade statistics for a university course. The program asks the user for results from different students on the course. These include exam points and numbers of exercises completed. The program then prints out statistics based on the results. Exam points are integers between 0 and 20. The number of exercises completed is an integer between 0 and 100. The program keeps asking for input until the user types in an empty line. You may assume all lines contain valid input, which means that there are two integers on each line or the line is empty. An example of how the data is typed in. So our program is first going to prompt the user who is using it to input the statistics, right? The grades. Right? It's going to ask for exam points and the exercises completed. So right off the bat in my head, I'm thinking we're going to need a loop, and most importantly, because we don't know how many times we're going to be running that loop, right? It could be a class of 5 students. It could be a class of 30 students. We don't know, but our program needs to be able to be flexible enough to work with any given number of students. So we know that we're going to need a while loop because, as I've discussed in the previous video, while loops are very good when you want to loop or want to have iterations or loops in your program, but you don't know how many times you want to do it for. That's why we use a while loop. But again, with while loops, we just need to have a way that we can terminate or exit that loop. So when we get to writing that code, you'll see that. But this is what as I'm reading this sample input, that's what I'm thinking in my mind. I'm thinking, hey, we need a loop because we need to read in information over and over and over again. But we don't know how many times we're going to need to do that because the students in this course could be 4 students that we see here in this example input. It could be 20 students, it could be 30 students, but our program needs to be dynamic in that sense to be able to read in any number of inputs. So here, we're looping 4 times or we're looping 5 times, but in the 5th time we exit the loop. So first input is 15, so 15 will be the exam points, and 87 will be the number of exercises completed. here we read in 10 and 55, then 11 and 40, then 4 and 17. And then when we input an empty line, we go straight into printing something new, which means that this is where providing an empty line or an empty input is how we kick ourselves out of that while loop. Okay. When the user types in an empty line, the program prints out statistics. They are formulated as follows. The exercises completed are converted into exercise points, so that completing at least 10% of the exercises grants 1 point, 20% grants 2 points, and so forth. Completing all 100 exercises grants 10 exercise points. The number of exercise points granted is an integer value rounded down. So this is a pretty big hint, and we'll talk a little bit more about that in a second. The grade for the course is determined based on the following table. 0 to 14 is fail, right? You get a grade of 0, which is equivalent to a fail. 15 to 17 is a grade of 1. 18 to 20 is a grade of 2. 21 to 23 is a grade of 3. 24 to 27 is a grade of 4. And then 28 to 30 is a grade of 5. So 30 is the most we can get when you combine the exam points and the exercise points. So the number of exercise points is an integer value rounded to 10. So we need to convert the exercise points into an integer between 0 and 10. So we'll do that. I'll show you how I do that. It's very, very straightforward. There is also an exam cutoff threshold. If a student received less than 10 points from the exam, they automatically fail the course, regardless of the total number of points. And then with example input from above, the program will print out the following statistics. So we'll print out this line statistics, then points average, then pass percentage, and then grade distribution, which is this little graph with asterisks that show where the students land over as a grade distribution. Floating point numbers should be printed out with 1 decimal precision. We learned how to do this, how to format strings, decimals. We'll do that as well. And then here is just this extra note that they sometimes write in the exercise descriptions. It says this exercise doesn't ask you to write any specific functions, so you should not place any code within an if name is equal to main block, if any functionality in your program. In the main function, you should include the code calling this function normally and not contain it in an if block like in the exercises which specify certain functions. Here we have a hint. The user input in this program consists of lines with 2 integer values, exam points, and exercises completed, like this. So we enter them into one line, right? We don't read exam points and then read in exercise points. We need to read in those 2 data points in one line and then be able to split that line into each specific variable. You have to first split the input line in 2 and then convert the section into integers with the integer function. Splitting the input can be achieved in the same way as in the exercise first, second, and last words, but there's a simpler way as well. The string method split will chop the input up nicely. You will find more information by searching for Python string split online. We've already covered the split function with strings in Python, so we don't have to worry about that. But again, as we're writing this code, I'll talk about that as well. Okay, so I have VS Code here open. You can see in the previous video we covered exercises 33 down to 37. Right, you can see the green dot here. So exercise 38 is the last one that we have to do. So I'm just going to go ahead and collapse all of these and just leave this open. And so if you double click gradestatistics.py, it's going to open this up. I have the Python extension running in my VS Code workspace here. So far so good, as I'm checking OBS here in my other monitor, and we haven't lost any frames. So hopefully that continues, but I have it opened here just so it makes it a little bit easier to run instead of having to manually navigate into each folder and then run Python manually in the terminal. We just have this little run button up here that's going to do it for us. Okay, so before writing any code, we need to understand what the program was asking us. So we're giving, again, if you go back to the exercise here, description, we're given multiple lines of inputs like this, right? Each line contains our 2 important data points, the exam points and the exercises completed. So, and they're inputted into one line. So 1587, 1055, 1140, 417. So each line represents that student's exam points and exercises completed. So we need to, from these, get the average points, the pass percentage, and the grade distribution, which is what we print out as our statistics. So our first group will be reading that input, right? So again, the way I'm thinking about this, we need to split this into a couple of stages, right? So the first phase will be reading the inputs. The second stage will be processing the input, right? So stage one, prompt the user for those inputs, right? Read the exam points and the exercise completed, and then into one line, and then split those into integers so we can do something with those values. Then the second phase will be, okay, now we gotta process this data, right? We gotta process the exam points, and we have to process the exercises completed so that we can print out those statistics. And then this third phase will be, formulating our output, right? So all those calculations done, we need to print that out back to the person using our program. Okay, so we know that we're going to need to be able to store our stats somewhere, right? It'll probably be the easiest way to work to achieve our desired output. So we're gonna have a list that's going to hold our statistics, right? So just for reference, the exam points and the exercises completed, I'm going to reference those as the student stats. So we're going to create a list here, a variable called stats, which is going to hold an empty list, right? Because we don't know how many students we're going to have for the course whose data we're going to have to work with. So we're just going to open up an empty list and call it stats. Then we need to be able to populate this empty list with data. So remember, when we were reading the exercise information, we knew right off the bat that we're going to need a loop. And not just any loop, we're going to need a while loop, because we don't know how many times we're going to need to loop over and process that information, to process those statistics. So we're going to use a while loop, or I should say a while true loop, right? Because we just need to be able to break out of this. But our loop needs to remain true, so we can run it over and over and over again until we go through the entire list of students and their exercise and points data. So while true, we're going to take in a user input, store that as an input, and then prompt exam points and exercises completed, like that. Then we're going to do our if statement. If user input is an empty string, then we want to break out of this loop. Again, we've seen this a million times. Actually, it should be that's what I'm getting that error. A double equals, right? And then break. We've done this a bajillion times up until this point. This is one of the easiest way to break out of a while true loop. So if we do input an empty string, right, we need to check it, and if it is, then kick us out of the loop. Otherwise, we can continue with the rest of the loop. So now we need to be able to split this input into two values, the exam points and the exercises. Actually, in fact, I should do it like this. Exam points is equal to user input dot split, and then get the first value, and then exercises will be user input dot split, and then second value. So we use that split here, and we don't. You probably thinking, why we're not doing this, right? Because we could, for example, make a mistake in our input. In fact, let me actually demonstrate this. So I'm just going to save this, and I'm going to hit the run button up here. Here we're getting prompted. So let's enter 15 and 87 like that. And if we enter an empty string, it automatically breaks us out of our loop. So we know this is working fine. But let's say, for example, that we did do this. All right, and let's run this again. So 15, 87, and let's do 15 and a bunch of spaces, 87. So this also works, but if we by accident put a bunch of empty spaces, we can let Python handle it by just passing nothing here. Python will automatically split the string based on any given number of spaces here. So this is how I'm going to split our statistics. In fact, actually, what I should do here is do stats that append, and we need to convert integer exam points, because right now it's still strings, and then integer exercises like this. And then outside of here, we're going to print stats. I'll use an F string, and then you just put stats. Let's run this again. 1587. Oops, excuse me. 1587, 15, and a bunch of spaces, 87, and then empty space, and you can see it's still working. 1587, 1587. I need to remove this line. So this is one way that we can split our our user input into two variables, but we can also do it like this. We can declare our variable names. So we want to split our input into two separate values. So the first value will be called exam points, and our second value will be called exercises. Then we set that equal to user input.split, and then we get rid of this index target, or we don't want to target a specific index because we're extracting two values. And then this will also work. So now if I run this, let me go down here and clear this. So if I go and run my code, right, 1587, 10, and 44, right, it still works. So this is a more inline, cleaner way of splitting a string and into two separate values. In fact, you can do this for a number of variables. Let's say, for example, something like this, or count like this. And then let's say I then append count here as well. Right. So now if I run this, let's say, for example, we want to write in what they got as their exam points, their exercise points, and then what number of students this is. So this is student 1. Then we want to do 10, 44, student 2, right? So now we can also do that. So we can do this for a number, any amount of values that we want to extract from our string. So if our string input is like, we want to get like 4 or 5 or 6 different values, then we can just comma separate our variable names and set that equal to user to input.split. Okay, so that's just a neat trick in Python that we can do. Okay, so we've done that. Now, why are we saving our values like this? Why are we nesting our list, right? Because we have this opening or this wrapping list, and then each index in our big list is another list. This is just easier in terms of grouping, so that we can associate each index to always have values stored for each student, right? So instead of doing like this, in fact, actually, I don't even think this will work, because we might need to do it individually. Like, we need to append one at a time. But let's run this and see what happens. So 1587, right? This gives us an error, right? So we'd have to do it like this, and then do append again, and do exercises like that, right? So all this works, and what it's going to do is it's going to create a list like this. So it's going to be 15, then 87, then 10, then 44, right? This works, but you might just have to, at least when I was thinking when I was doing this, is like, hey, how can I make this a little bit easier to work with, in a sense that each index should store values particularly associated to the student being processed at that time. So the easiest way to do that would be to do nested lists. So now, in our list, we have a nested list, which contains the exam points and the exercises completed for that student. So this mini list here is one student. Then the next mini list, right, the next nested list is the second student, then the third student. So it's easier to work with those data points like that way, instead of listing 15, then 87, then 10, then 44 as individual values in a list, and then having to associate each subsequent value of our list to one student. So the index 0 and index 1 will be one student. Then index 2 and index 3 will be the second student. Then index 4 and 5, et cetera, right? But in this instance, it will be a lot easier if index 1 has the values for student 1, then index 2 has the values for student 2, then index 2 will have another nested list that points to student 3, et cetera, et cetera. So that's why we're doing it this way. We're doing it this way instead of appending individual integers like that. So hopefully that makes sense and is a little bit, explains why we're doing it this way and not any other way. Okay, so up until this point, we're doing no calculations. All we want is to read in an input, split that input into two integers, append those integers into our stats list as nested lists. Now, what we need to do is convert this data into meaningful values, right? Remember, we need to get the exercise points based on the number of exercises completed. So we remember that which what I was talking about here. Where is it? Right, completing all 100 exercises grades, 10 exercise points. The number of exercise points granted is an integer value rounded down. So we need to be able to take the number of exercises completed, like 87, 55, 40, 17, and convert that into a single integer value between 0 and 10. So how do we do that? Now this is where functions come in handy, because we know that we're going to have to do this for every exercise, every student that we process. So instead of having to do this manually in a loop over and over and over again, we can just define a function and then call that function each time that we need it to give us that value. So I'm going to define a function here called exercise points, which takes in the number of exercises completed. This is an integer. And then what we're going to do is just return exercises and use the floor function or the floor division, right? So exercises divided by 10, and then we know that this could return, or would return, a decimal number. So we want to round down to the nearest whole number. That's why we do the double forward slashes here, and then we just return that. So in our example, so let me run this so you can, again, we can see the data. Yeah, let's just run it. So 15, 87, 10, 44, etc. So this function is going to take this value, 87, or this value, 44, and divide it by 10 and round down. So 87 divided by 10 will be 8.7. But we want to round down to the nearest whole number, so it's going to give us 8. 44 divided by 10 is 4.4. But we want a whole number, so we're going to round down to the nearest whole number, which is 4. So this is going to return 4. So so you're going to see again, we're going to have to go through our stats list again, and then extract these individual values, and then pass those values into the exercise points function. Okay, so again, hopefully that makes sense. So our exercises is between 0 and 100, and then we need to get that down to 0 and 10 so we can get those whole numbers. Now we need to also define a function to calculate our grades. So our grade is the total points plus the number of exercises, the exercise points, and then that should equal a whole number. So essentially, we're going to extract this value and this value independently. This value we pass into exercise points function and return a whole number between 0 and 10. And then the number returned will be added to this, and that's going to be what helps us calculate our grade. So here I'm going to define another function called calculate grade. We're going to pass the exam points, and we're going to pass the exercise points. Then we're going to say if exam points is less than 10, return 0. So why do we check this first? If you remember from our instructions here, this line here, there is also an exam cutoff threshold. If a student received less than 10 points from the exam, they automatically fail the course, regardless of the total number of points. So exam points plus exercise points equal our grade, or help us determine our grade. So if we fall anywhere within this range, we get a grade of 0. If we fall anywhere between this range, we get a grade of 1. However, if we receive 10 points or less than 10 points from our exam, then we know that we automatically fail. So that's why we do this check here first. Otherwise, we're going to do if we're going to calculate the total points, set that equal to exam points plus exercise points. And then we're going to do if total points is less than 10, less than or equal to 14, then we return 0. Right? This is the first group here. Right? First group, 0 to 14, you get 0 or you automatically fail. So you can do it this way. You can do if total points is greater than or equal to 0 and total points is less than or equal to 14, then return 0. Right? And you can keep doing this. You can do elif here. Total points is greater than or equal to 15, and total points less than or equal to, what is it, 17? Right, 17, then return 1. And then keep going, 18, 20, 21, 23, so this would be greater than 18, less than 20, return 2. Greater than 21, less than 23, return 3. Greater than 24, less than 27, return 4. And then else, return 5, right? But, oops, I misspelled this, exercise points. But since we already have this, we know that we don't have to worry about any value less than 0, right? Because we know our exam points can never be less than 10. So we can just do this, right? So anything between 0 and 14, so this would be anything between 0 and 14, return 0. Same thing here. Anything less than 17, return 1, right? But this would be, so if we get a number greater than 14 but less than 17, it will return 1. And then here, if we get a number that's less than 18, pardon me, less than 20 but greater than 17, it will return 2. This will do any grade less than or equal to 23 but greater than 20, returns 3. Any grade less than 27 but greater than 23, returns 4. Otherwise, return 5. So this is just a little bit of a cleaner way to do that else if total points is less than this and also less than that, blah, 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 or greater than 14 but less than 17, right? This is just a little bit more streamlined. Now we guess, okay, so we did our loop here. We have our stats. We defined our first function here to get the exercise as a number between 0 and 10. And then here we calculate the grade based on exam points plus the exercise points. Okay, now we need to be able to loop and calculate some variables. So I'm going to go up here. I'm going to declare some more variables. Point sum, so that equal to 0. Passed is equal to 0. And then grade counts is equal to an empty list of 0, 0, 0, 0, 0. We need 6, right? Yeah, 6. And save. So this is the total number of points. If you go back down here to the how we print the statistics, we know we're going to need to get the points average, so we need to keep track of the total points of all the students. Same thing, we're going to need to be able to calculate the pass percentage, so we need to calculate how many students are passed. So that's what we're keeping track of this. And here we have an empty list. We have a list of integers with 6 indexes, all initialized as 0. How do we know that we need 6 indexes? If you look over here, we know we're going to have to print this grade distribution. So the grade distribution will basically print out a number of ticks based on how many students get that grade. So if we have multiple students get 0, maybe let's say 3 students, so this will print 1, it will print 3 asterisks, signifying that 3 students got 0s. And then 2 asterisks here for how many students got a grade of 1, and so on and so forth. But as you can see, there's 1, 2, 3, 4, 5, 6 indexes, right? We start counting at 0, even though it goes up to 5, we start counting at 0, but this will be 6 lines printed. So that's why we're initializing each thing here as 0. And then we're going to, based on the amount of grades returned, we're going to populate these values accordingly. All right, so hopefully that made sense. So here we're going to need a for loop. I'm going to get rid of this. We're going to say for exam points and exercises in stats, right? So now this is our way of destructuring our nested list here of stats that's going to print out these nested lists like this, right? We're going to say for each index in our stats, extract the two values in that nested list. That's how we're doing this. Instead of doing nested loops, it's a little bit of an easier way to do that. So we'll say for exam points, comma, exercises in stats, we're going to set exercise points is equal to exercise points, and then we're going to pass exercises, right? We define this function up here, which is going to get us this integer between 0 and 10. Then we're going to say total points is equal to exam points plus exercise points. Then we're going to call the grade function here. We're going to set a variable called grade, call the calculate grade function, pass exam points and exercise points. And then here we're going to say points sum plus equals or is equal to points sum plus total points. And then we're going to say if grade is greater than 0, that means a student has passed. Then we're going to do passed is equal to passed plus 1. So this is what this variable is tracking, how many students passed. Please excuse me, I just have to. Okay. Right, so passed, as we see over here. Right, we need, if you get a grade of 0, you automatically fail. But if you pass, it's if you get a grade greater than 0. So if you get a grade of 1, 2, 3, 4, that means you passed the course. So that's why we're checking here. Right, if grade is greater than 0, that means you pass, and so we need to increment our passed tracker up here by 1. Okay, and then grade counts, grade plus equals 1. So what we want to do now is go to our this list here with 0, 0, 0, and then for that index that our grade returned, we want to increment by 1. So if somebody gets a grade of 0, right, that means they fail. That means we increment fail by 1. If somebody gets a grade of 1, then we increment index 1 by 1. If somebody gets a grade of 2, then we increment index 2 by 1, and so on and so forth. This is what this code is doing here. But for the sake of simplicity, I'm just going to go plus equals 1 here and just leave it at that. Okay, now we need to calculate some statistics. So I'm going to exit this loop here. We're going to have we're going to calculate the average. So here the average is going to be our points sum divided by the length of our stats list. Then we're going to have the pass percentage, which is going to be the number of students passed divided by the length of our stats list times 100, because this needs to be a percentage value, so between 0 and 100. And then we're going to need, and then we're going to have to print the grade distribution, right? This should be the only thing we'll print out here. Right, points average and then pass percentage. So in fact, what we can do here is just go ahead and print statistics like that, so we can just see this a little bit. And then print, we're going to use f strings here. Excuse me. I'm going to say points average and average. And if you remember, this is how we, sorry, not like that. This is how we format floating point numbers. So we want to print 1 decimal after, so we do 0.1. And here we're going to print the passing percentage. And again, pass percent, like that. And then we're not going to do this yet, but I'm just going to print it here. Grade distribution. And then we're going to have to handle, this will be this section. So if I were going to print this and this, we're going to print statistics, then this, and then it's going to print this line, but it's not going to print this out yet. So let's go ahead and run this and see. Actually, before we do, let's go ahead and run this. And what's so 1587, 1055. So 1587, 1055, 1140, and then 4 and 17, and then exit out. As you can see, we get statistics printed, points average printed, pass percentage printed, and then grade distribution printed as well, but it doesn't have anything that comes after. We're going to have to do that ourselves in just a second. So, which is looking pretty close to this, right? 14.5 and 75.0, which is the same in calculations that we get ourselves here. Okay, so now we need to calculate the graded distribution. So right above here, maybe here, I'm going to define a function called grade distribution. It's going to take in the grade counts list, and then we're going to loop. Wow, I spelled that completely wrong. We need to loop through this list, and then just print out those asterisks in a way that looks like this. So we're going to say for grade in range 5, 1, 1. And if you remember in the range function what we learned, right, this is how many times we want to print. This is where we want to stop, and this is what direction we want to move. So we're saying, hey, start printing from 5, stop when you get up to -1, and then decrement, right? So it's going to print 5, so it's going to do this. It's going to print 5, 4, 3, 2, 1, 0, and then it's not going to print anything else, right? So this is everything up to -1. So 5, 4, 3, 2, 1, which is what we want to be printed here. And then this -1 is telling Python, hey, count down to get to 0. So it's going to print 5, 4, 3, 2, 1. That's what this is doing. And then we're going to say print, I'm going to use an F string here, the grade, and then the number of asterisks. Let's just put grades here. Like that. So essentially, print one of these values, right? 5, 4, 3, 2, 1, 0. So this will be 5 preceded by this colon and then the number of asterisks. The number of asterisks will be the asterisk string multiplied by whatever value is at that index. So at index 5, right, that'll be, well, not index 5, but at grade 5, that'll be the whatever value is there multiplied by the asterisk. So if this, for example, is 3, then it's going to print 3 asterisks. If it's 2, it's going to print 2 asterisks. If it's 1, it's going to print 1 asterisk. If it's 0, it's going to print 0 asterisks. It's going to print, no asterisks. And that's it. So now down here, we're going to go back, and we're going to call the grade distribution function, and we're going to pass the grade counts list. And then now we're going to go back here, and we're going to run our function one more time. So the first value was what? 15 and 87. Right, 15 and 87, then 10 and 55, then 11 and 40, and then 4 and 17. And then there we go. Grade distribution. We have nobody who had a grade of 5, nobody who had a grade of 4, so there's no asterisk being printed here. We had one person have a grade of 3, so it did 1 asterisk. And we had nobody get a grade of 2. We had 2 people get a grade of 1, so it prints 2 asterisks. And we had one person fail, which printed a singular asterisk. So that's it. I think that's the solution to this exercise. If you have any questions, please let me know in the comments below. This is one of the things where once I started thinking more about what the exercise was asking, it was a lot easier to write this solution. So if you have any questions, if there's something that was confusing for you to understand, let me know in the comments below, and we can talk a little bit more about that. But I think this is the ideal solution for this exercise, right? We use loops, we use lists, we use functions, and we use 2 different kinds of loops as well. So I think this should be it. So let me run this. There we go. I hit the test button on the, as you can see here, the little I that was up here. All the tests passed. Sending that solution to the server, and if I go back to the browser and refresh, yay, we got awarded our 1 point. And that's it. We're done with section 4 in its entirety. I'm just going to do this feedback quiz off screen. If you have it on your end, please do it. It's really helpful for the university to be able to assess how people are doing in this course, to improve material, and et cetera, et cetera. So if you have any issues, definitely voice them in this feedback quiz. If not, you can leave it blank. If you don't want to participate, it's optional. But I think it's really useful, and it helps improve the course material for people who are taking this course in the future. As tradition, let me log into the TMC website so we can see the model solution as well. Okay, so this is the model solution. Here they define a function called exam and exercises completed. And so instead of splitting the input as what we did, like this, let me close this. Like how we did here, they define a function that reads the input and then converts the exam point. So basically, from the beginning up to the first space, set that equal to an input, and then from that, for everything else, set that also equal to an input and store it into this exercise variable, and then return this list of exam and exercises. Then here they did the same thing that we did to calculate the exercise points. They did the same thing practically for what we did for the calculating the grade, but we used this when we were printing the grade distribution, but they also used it to calculate the what the grades are, and they set up this list of boundaries to basically return what the grade is. So if you get a grade of points that fall between above the bound, somewhere between the boundaries, it will return whatever that value is. So if you get 0 and 15, between 0 and 15, you get a grade of 0. And so on and so forth. You get 15 and 18, you get a grade of 2. 18 and 21, a grade of 3, et cetera, et cetera. A grade of 1, a grade of 2, a grade of 3, up until a grade of 5. Here they have a function that calculates the mean. We just did this inline in a variable. Then they define this main function, right? They have this empty list of points. Then the grades, which we initialized as an empty list with a bunch of zeros in it. Then they have a while true loop, like what we did, to read in however many times that we need to read in the data for each student. Then append those values to the points list, then the grade to the grades list, and then calculate the grades here, like here, and as well as, what is this? And this is appending to the grades array, not here. Got that confused. Right here is call the grade function, which is this, to calculate what the grade is for the student, and then append that value to whatever index is in the, okay, I see what this is doing. So basically, instead of doing 0, 0, 0, 0 6 times, they did an empty list of zeros and each index, in which 6 indexes. So this is a pretty neat way to do that. And then append for whatever, like what we did here, what we did, where is it? Here is what they're doing here. Okay, then here to get the pass percentage, they do that, similar to what we did 100 times, but we did, again, because the difference is in how they set this stuff up. And then they print the statistics here. And then they call the main function. So everything that runs, right, that calls all these other functions is defined in this main function. We didn't do that. We just did it like this, how we normally do. But, and again, the solution still worked. But you can do it the way that they did it. Define everything that's going to be called in this main function, and then call the main function at the end, and then define all these helper functions outside of main. Right? You could do it this way. You could also have done it doing the if name is equal to main, then you would have put all this stuff under here, and then call those functions, but again, unnecessary. But yeah, and then that's it. So pretty similar approaches. They just defined a lot more functions than we did, and then called everything that needs to be called inside this main function. But for the most part, our solutions are pretty similar. I think my solution might be a little bit easier to follow outside of this line here, but I'll probably just put a comment here. like that. But yeah, so I'm gonna upload the solution to GitHub. If you have any questions, like I mentioned before, make sure you ask them in the comments below. If you need me to expound on anything covered in this video, let me know. If not, I'll see you guys in the next video. We'll get to start part 5. And we have what? 2 more parts? So we have part 5, which is 4 sections. And then we have part 6, which is also 4 sections. And then part 7, which is 6 sections. So we have 2 more parts before we get to the final part of this course, the introductory part. And then if people are at that, when we complete part 7, would like me to continue with parts 8 through 14, then I'll do that as well. But if you get to part 7, you can go ahead and take the exam and then get your first certificate, which will be the Introductory Programming in Python certificate from the University of Helsinki, which covers parts 1 through 7. And then you can go ahead and do parts 8 through 14 to get the second certification. So yeah, I'll see you guys in the next video. Thank you so much for watching. If you have any questions, please make sure you leave them in the comments below. Check out the GitHub repository. If you just want to get straight to the solution and don't want to hear me rambling and explaining my work, please give that GitHub repository a star. Please, please, please. If you can do that, I really appreciate it. It just gives me more feedback that you guys are finding values from my solutions. Give this video a thumbs up. And if you haven't subscribed, hit your bell with the subscription. And stay tuned for the next video. Hopefully, we'll come around either Thursday or Friday of this week, in which we get to start part 5. All right, peace.